Thank you.
Okay, so let's start back. So we are going to start the, let's say, workshop about digitization of the building sector as enabler for the renovation wave. So what we are having this session, this workshop, welcoming 4 or 5 different projects, and few of those, we'll say, are actually in the same European topics, and they so technically sister project and about to finish. So what we want here is to share our insights, share our views of what are the, our outputs on how BIM can help practically the renovation. So I'm Antoine Duguet. I'm working in Novatec in France, and a research technical organization, and I will act as a moderator introducing the different speakers. And then I will ask a few questions to them and their views on this very important topic. So the first presenter, a bit as an introduction, will be Sway Subra from the CSTB. And apart from being an employee from the CSTB, Sway is also the head of the EU BIM task group. So Swell will tell us what is this group, what is his role, and what they aim to accomplish.
Thank you, Antoine. Hello, everybody. It's a pleasure to see you all here in this wonderful place, right? So I'm making this presentation about digital construction and BIM in the EU. As a start, let me remind you that the construction sector is an important sector with more than 8% of GDP, right? But it has a long record of poor performances. So, for instance, the McKinsey report states that in the last decade, productivity in the manufacturing has increased, nearly doubled, whereas in the construction sector, it remained the same, and in some areas even dropped, which is a big problem, right? But it's not only about productivity. I'm going to stand up much more comfortable. So, but it's not only about productivity, right? So it's about if you consider that the built environment is the space which people live, recreate, and work on all that. It means that it strongly affects all the environmental, economic, and strategic development as a whole. And therefore, it needs to be healthy, it needs to be comfortable, it needs to be safe, it needs to be sustainable, obviously, and so on, which is a big challenge. So another big challenge is, of course, you know that renovation. Renovation is a major challenge because the stock of existing building is huge. It is obviously very important, something like 85% of the existing building. And this stock is made basically non-efficient on the energy level, because it was built in a period where there were no energy performance requirements, right? So we have this huge stock. The rate of renovation of the stock is very low. If you consider that we need deep renovation to improve energy efficiency, let's say by 60% or so, we only have 0.2% of the stock that is renovated each year, which is very, very low. And at this stage, it means that we obviously will not meet any of the aims concerning the reduction of carbon emissions in centuries, right? It will be very, very long. And therefore, it is really time to act. And this is basically what the EU is doing through the Renovation Wave strategy. So this strategy was launched by the European Commission. It aims at doubling the rate of renovations and modernizing existing stock. And it also aims at contributing to the green and digital transition in Europe. And there are 3 actions that are mentioned and that obviously you will be interested in. in this strategy: the digital building logbooks, the building permits, and also bid for public procurement. And I will go back to these items as I go. So, in that context, the EU Plus Group addresses some of these issues. So, what is this group? It is a European platform that that is composed of public procurers and policymakers, and aims to bring collective expertise to improve building deployment in European countries. And this is a major issue for us. I chose here a photo with Richard Petrie, late Richard Petrie, as a member of the group, as a tribute to my friend Richard, who passed away a few months ago. Obviously, we want to share common best practices between European countries. So some of the countries are more advanced than others. So how do we share these best practices? How do we make it possible for European countries to improve their building journey? And also a major point is that we need to bridge the gap between the demand side on one hand and the supply side on the other. We have requests coming from the public side, right? The public side requests some improvements, some features regarding the deployments. But we need to make sure that the industry and the private sector is answering these requests. And therefore, we bring together these two parts by contributing, by putting in contributions coming from obviously the group itself, but also by enablers, what we call enablers, that are the standardization bodies and also the innovation centers. So we have 26 members in countries in the group. They are European countries in the EU and also outside. We have also Switzerland, Norway, the UK, and we are happy to have the European Commission as our sponsor. So some of the deliverables by the group, I'm saying that to give you some information because most of this material is on the website. Please go check it. I think it will be interesting to you. So the first word was around what we call the handbook. The handbook is a major contribution and aims to be a central reference point for the introduction of BIM in the sector. And it was developed as to equip governments with the knowledge needed to deploy their strategy. It is now available in 23 languages, and it can be, as I said, downloaded from the website. Yeah. Another action that I think is of interest to you is the cost-benefit analysis that was conducted by the group. Obviously, this is also a major issue. I mean, one of the first questions that we have every time is how much does it cost? What are the benefits? And it is more important, I would say, in the public sector. So what we are doing is we are trying to answer this through a scientifically sound methodology. So that was an action that was conducted by the Italian consulting company called Rina, and with a finance by the budget coming from the European Commission. So to develop a cost-benefit model that is scientifically sound and that can be validated. And this model was validated using 6 case studies. I will present to you the rest of the case studies. And the third deliverable was a handbook that is an important document that presents the model, the use cases, and make people understand what is done in this action. The case studies we used to validate the model are very different, obviously, because we needed to make sure that we cover the whole spectrum. So we have case studies coming from various countries in Europe. We have projects of buildings, projects of infrastructures. We have various types of budget, important budget, but also small budgets. And obviously we cover all the phases. We have the phases of design, but also the phase of renovation, right? So it covers all these activities. Again, all this material is also available on the website, so please go ahead and check it. And the action we finally worked on is a white paper that we prepared for the European Commission. You probably know the European Commission has a public procurement directive that was published in 2014. This directive was very, let's say, not very ambitious on the bid level. It only said that procurers are engaged, or the use of BIM for public procurement is suggested. So the European Commission is now working on a new directive, and we are pushing for the new directive to be more ambitious on the BIM level, and we are providing the European Commission with again with some information to back this argument. In the white paper, obviously, we underline the importance of using public money and make sure that you can use public money in the right sense. And to do so, we underline the importance of using open standards, because open standards is very important in a way that they allow, in fact, to make sure that public procurers are not stuck with one sector or one solution, right? So finally, I just want to draw your attention to the work that is going on the high-level construction forum. It is, I think, a very interesting forum that aims to initiate the cooperation process of transition pathway between green, digital, and resilient transitions. And this is done under the invitation coming from the EU Commission. About more than 200 representatives are attending these forums from different countries, coming from the private sector, the public sector, and all kind of stakeholders. And they had very different sessions that were organized. And in the digital session, it was underlined the importance of the digital transition as a means to ease the green transition. I mean, the green transition needs to be founded on tools, on models, on very sound methodologies in order to be able to address all the challenges that are out there. And the digital transition is the way to do that. And also some of the issues that were underlined, the importance of trust, collaboration, and interoperability. It is a very important, I think, topic. The importance of public demand through public procurement as a way to improve the dissemination of BIM, and also the EU Data Act. The EU Data Act is a very important act that was voted, and I think it is a very important way to level the playing field. And finally, as in these sessions, of course, we address various questions, and one of the questions was, what is your vision for digital construction? And this is the cloud, word cloud that was yielded from this exercise. And I think it is important. I think it is also can be the start of our discussion here. And as you see, the importance of standardization, digital twin, digital logbooks, education, data sharing, digital platform, and so on and so forth. I think it is a very important way to structure some of the discussions we had. I think that's about it. Thank you again for your attention. I hope we all have a very fruitful session. And back to you, Antoine, for the rest. Thank you.
Since that's a very good introduction, so it's really highlighted the benefits of using BIM and how the Commission is trying to help on this topic. One of the ways is to fund some R&D project, and now we are going to have some kind of testimony from 4 different projects. Each of those is going to share some specific outlooks of how BIM can help the renovation practices. So the first one will be my colleague Pierre Bourreau, coordinating the different projects. So we'll have here a specific view on the initial part of the process, which is about the early digitization of existing buildings.
Okay, thank you, Antoine. So yes, indeed, my speech will be focused on this initial part of the renovation project, which is about digitalization of existing buildings. And when we speak about digitalization, what you may think of initially, or if you go to Google and put like digitalizing existing buildings, what you will probably find first is this kind of things like laser scanners and LiDARs and this kind of cameras where you can collect a lot of data in an existing building. Technologies are evolving, we have different shapes now for these technologies. So drones are now used to collect information on the envelope of the building. You can see also some people with some bags, and they go travel in the building, and they have these kind of things as well collecting data. And now also we have robots that can be used to do so. This is really nice, and it's like wow, high tech, right? And what do this produce? Once you collected the data, you have some massive files that you need to proceed, and you have like hundreds of pictures of one flat, and you can recreate the environment, or you can have point clouds, millions of point clouds representing geometrical building and the different parts and so on. Okay, but so you've done that, you're happy, you've used the laser technology, but now what can you do with that? So you have a renovation project, and what can you do with this data? So as my opinion, and that's the approach we took in the different project, this is nice, but this is empty, right? This is like an empty shell. You have a lot of data, but you cannot do much with that. So perhaps this kind of data is more useful for your renovation project. Perhaps an Excel file with a quantity takeoff of your building. This is more useful to people who need to install some new installation for your building, because they have the exact quantities and so on. They don't have to look at the point clouds and so on. So perhaps this is really much useful. Or if you want to have some information about the status of your building, energy audit is more useful. So the idea is that when you start with digitalization and BIM, you really have to look at your needs. And BIM is not 3D. Again, I think now this is more and more well known, that you need to attach more importance to the data that you want to be part of your model. Yeah, the value of BIM is in the data. And so our approach is that BIM is methodologies, not just digital tools. And part of this methodology is also to try to identify exactly what are your needs and what kind of model you want to build up for your renovation project. So let's start to draw a workflow for a typical energy renovation project. And as a first step, we want to define the data that we need. So yeah, in this kind of scenario, we know more or less what we want to change in the building. So we know that it's about ventilation, we know that it's about HVAC systems, the openings, and that's what we want to modify in an existing building. So what do we want to do when we start our goals for this renovation project? We want to guarantee the energy performance of the renovation. So we need to be strong at that to ensure customers about the energy reduction that we can ensure to him. What is perhaps even more important to him is what the cost of the renovation. This is crucial, of course. If you want to go further, you can potentially import also on the carbon impact and estimate the reusability of some materials that you will remove in the building during the renovation and so on. So you can have different actions that you want to perform in the renovation project, or different goals that you want to reach. How will we do that? The energy performance, basically, it will be done through some energy simulation. You will have to perform some cost analysis, life cycle analysis, and reusability audit, for instance, for the building part. And then once you have answered those questions of what are the data that you need or that you will generate during this process. For the energy simulation, you need some data on the envelope, you need some data like on the thickness of the insulation, the kind of material, resistance that is embedded, the type of glazing on the building. So you can list all the information that you on cost, the cost of the materials, the bill of quantities, the cost of the manpower, incentives, the return on investment, and so on. So you can list all the data that you will need to perform the different actions that the different goals that you have in your project. Okay, so once you've listed all this data, what you need to do is to map them into a schema to know exactly where you will put all this data in your model, or perhaps will you put all this data in your model? Manpower, cost of manpower, I don't know if that's will be part of your model, you will need that at some point. But so we need to transform all of this data into some big data as much as possible. And then the second step, once you have identified all the data that you need, is to pick up, to choose the right tools that you need to create your model. So if you need the geometry, for instance, so we've seen already that you can use some laser scanning, but if you want to create your 3D model out of it, it can take quite some time, because you need to clean up the point clouds and we build the 3D beam geometry. What we've done in BIM is okay, perhaps we don't need that much details into in the geometry. So if I have some 2D layouts, for instance, I can use those, and we have a partner who has developed a platform with some AI algorithms. They can scan the 2D layouts and recreate a 3D BIM model out of it, and it's really quick, and you don't need to go on site and ask for business, schedule it, and so on. It's really quick. You can also use some GIS data. So this would be important to get an idea of the different shadowing, so shadowing that the building will have for and impacting its energy performance. And still, if you need to go on site, perhaps you don't need to have this big laser scanner. Nowadays, you have like iPads or other mobile devices with a LiDAR camera, and different apps are being developed using these cameras to do some fast scanning with your day-to-day smart device. So we have created initial geometry, and then we need to fill that geometry with some technical information. So if we consider the existing building, again, we have two versions, one on-site and one off-site. So off-site, if you have some technical documents about the elements that are already installed and present in your building, you can scan those text documents and extract all the technical information about those elements. If you don't have those, you can use a typical smartphone, go on-site, perform the audit, take the reference of the different products that are installed, damages, etc. Then go back to the office, take the technical information, and put those into your BIM model. So now you create your BIM model in this building, and for the typical renovation, what you want to do is to estimate different renovation scenarios. And what can be done, or we've done, is to build a platform where you can click on the different items that you want to change in a renovation. So perhaps the windows, and connect to a catalog of products and import all the technical information into your new model, so creating a new model for the building to be renovated. And then you can estimate energy performance with some energy simulation and so on. So I'm not entering that details as I'm focusing on the digitalization part. Okay, so my conclusions on this topic for the digitalization. Yeah, for the users, I think it's really, really important for the users to really identify the needs for every project that they want to, that they are working on. Perhaps every project is different, so every model that you will create is different, but you need to identify correctly the data that are useful for you in your project. Then you need to choose that wisely, because if you create big models with a lot of data and you don't need like 90% of the data that are in there, then the big model becomes chaotic. It's hard to open, it's hard to work with it, and you're missing the point basically. And I believe there are a lot of tools being developed, so it's so the selection of the tools done that easy. You need to have a correct state of the art of the different system. And for the developers, it's important to listen to our client needs, because sometimes we are in some high-tech process and we want to build up like a nice software that do so many things and so on, but clients, what they need, customers, what they need in general, things that are really, really simple. So create software that are simple to use, perhaps they'll perform something really specific, like we saw before, the 2D, from 2D to 3D recreation. But this is what customers want and need. And then if you're doing that, ensure some interoperability with some other software that will do some other things that are specific again. And I think that this digitalization part there are still many things to do, and compared to other BIM activities, there are no big players right now on this part. So I think there's room also for innovation and for many things to be created. So this is the point. So thank you.
So thanks here for reading those testimonies. And the next one will be from Galakis, Jorgos Galakis. For the Lima project here, we will have some outputs on different stages of the projects. And well, let's listen to both.
So, digitalization of the building sector, and more precisely, digital tools are used in involvement in renovation projects. The literature is a list of tools that have been emerged during the past decade, and actually tools that adopt BIM and others that go beyond BIM. Tools like the tools that are depicted here and are results of BIM projects, and other tools that have been developed by our sister projects. But what are the lessons learned from the implementation and the demonstration of such tools in actual, real life innovation projects? The lessons learned vary. There are many lessons learned, and actually, apparently, I could not cover all of them in a 10-minute presentation. What I would like to do in the next 8 minutes would be to provide some highlights about specific tools that are involved in the 3 different phases of a renovation project. And actually, lessons learned highlights with regards to tools that have been demonstrated on those phases, starting with the data collection process, and actually the collection of static data, where I'm referring to the BIM model population, generation, and tools that are involved here are scan to BIM, to semi-automate the process of transforming the point cloud data acquired by laser scanners to BIM files, where actually our focus is on open BIM files, and more specifically on IFC. Then how we enhance and enrich the result of scan to BIM, automated scan to BIM process with augmented reality, using the BIM as input, try to enrich this geometry, for example, with the material properties, HVAC systems, and other information. But more importantly, how we manage this information. We create a BIM model, but at the end, we need to know how we manage this information, how we access this information, how we make this information available to others. And for this specific task, I'm referring to building information modeling data management platforms. Going beyond the static data, but again in data collection phase of an innovation project, let's talk a bit about the dynamic data. And I'm referring to all the scheduling information that is required to the profile information of the usage of systems that is required to run simulations and reduce the gap between simulated and measured building performance. Here, tools that are involved are machine learning algorithms applied on IoT data collected from field on site. And based on that, try to learn how occupants use the HVAC systems and energy systems in general. Other digital tools that are involved in this collection process is apps for occupants. We engage the occupants from the very first stage of the data collection. And actually, what is really important is to learn from them what are the weak points of the buildings. They live in the buildings, they know what are the weak points, so this information that should be utilized to improve the measures that we are going to apply, innovation measures that are going to apply on the building. Again, all information should be somehow be manageable and interoperable. We collect all these, for example, behavior data models, and we need to make them interoperable and link them with the BIM information that was captured in other phase, in the previous step. Next phase, the design phase of an innovation project. Here, actually, we're talking about performing the energy audit, evaluate the as-is status of the building, what's the baseline, and based on that, provide some renovation scenarios, combination of renovation measures, evaluate them, calculate specific KPIs, and select the renovation measures that meet the user's targets. So here, tools that are involved are tools that utilize the as-is, static, and dynamic data, and automatically transforms this information to build-intense performance simulation models that could be utilized without any manual edit by the user. Other tools that are involved in this process are the innovation scenario generators tools, where actually utilizing state-of-the-art material and component database, we are trying to automatically generate candidate scenarios that could be applied on the building, evaluate their performance, and allow, through a decision support system, the user to select which measure is the one that meets his requirements. Last but not least, the construction phase, where we're talking about applying the innovation measures that were selected in the previous phase in reality. And here, tools that could be involved, and actually we developed and demonstrated in Beamer, are tools for the process modeling and simulation to simulate different combinations of tasks that need to run in the actual innovation, in the innovation project. And based on that, estimate time and cost KPIs of the whole process. Workflow management and monitoring tools, where actually we're talking about tools that are applied to monitor, track the progress of the innovation project. And finally, apps for workers and residents to support them, alert them, for example, to different safety issues, notify them about activities that will run close to their apartments, and so on. So, moving to the lessons learned. Starting with the data collection phase. With regards to scan BIM, I would like to present the lessons learned from the developers and the end user's perspective. So the lessons that we learned when we demonstrate scan BIM as a tool in our pilot sites is that low quality of the input data that we're collecting affect significantly the results of the scan BIM automated process and the generation of the BIM model for sure. So this means actually this is not a surprise. We know that the input data affect the result of a process. But this actually, the lesson learned from this specific tool is that the end users, the developers learned that some training of the people that perform the laser scanning is prerequisite to have high quality of data that are collected. From the user's perspective, and when I'm saying users, I'm referring mostly to BIM modelers. Actually, here we learned that it is really important to be compliant with standards and open BIM format files, because this way we enable somehow the true interoperability between the different tools and stakeholders, but also we segment the vendor locking. Moving to the BIM enhancement with augmented reality, actually within Beamer, the augmented reality, the application developed for augmented reality runs on HoloLens. And actually the lessons that we learned is that it really would make sense to focus on mobile apps instead of HoloLens, because the high cost of procuring such devices, HoloLens, is quite costly, expensive, could limit the replication of the tools and usage of these specific tools in other demonstration sites and innovation projects. From the developer side, we learned that real-time editing of IFC file to enrich the IFC file on site is quite challenging. And it is quite challenging because the files are heavy files, and running such heavy files on HoloLens with low capacity could make the whole process quite challenging. Moving to the BIM platform, actually within Beamer, we also developed a tool that maps information with regards to BIM. And actually, the lessons learned from the demonstration and validation of this tool is that to prepare an error-free BIM model that meets the requirements of business performance simulation and other tools that are involved in innovation, in an innovation study, is quite difficult. So, what is important to be provided by a digital analysis platform is to provide functionalities that allow around compliance, completeness, and correctness checking. And for sure, what else is quite important is when, okay, you detected some class errors, you detected some compliance errors, all this stuff, it would be nice to be somehow visualized. So the fact, this is why the main driver why in the second version of the specific tool, we implemented UX to see the results of all these compliance, completeness, correctness checks. From the user's perspective, again, a big modeler, it became a point that for sure working with open beams is really, really important. Performing automatically the detection of classes, detecting missing information, and proposing how to fulfill, how to meet the requirements for the Big Against Performance Simulation is really important. Apart from that, it's also important to provide open APIs that allows the end users to query the information that a BIM file includes. And based on that, see, for example, specific information that is included in an IFC file, and not all information that the BIM file could include, capture. Moving to data collection phase and dynamic data. Actually, part of the project activity is supposed to install IoT devices in Wiki to acquire all the dynamic data that required to train it on behavior models. And from these activities, we learned that equipment commissioning, but also data maintenance is also a challenge task. It's not only about installing equipment, you need to maintain the equipment to enable somehow the collection of data that are high quality and granularity. And actually, collection of those data is the main enabler for improved occupant behavior models results engineering. And as such, the main enabler for reducing the gap between BIM performance simulation that is measured and simulated. Moving to the design phase, actually there were many functionalities and components that were involved to calculate specific KPIs like conflict KPIs, LNS KPIs, sustainability KPIs, CLCA, and all of them we learned that it would be quite helpful to include all of them in a single product. And actually, to enable the evaluation of candidate innovation measures, it is really important to have a quite rich material components database that allows you to extract information from there, combine information, and based on the baseline information on the as-is information, propose innovation measures that could be applied on the building. The feedback from the users is that the utilization of a decision support system that allows you to evaluate different innovation paths, active renovation measures. And in terms of specific KPIs and provide recommendations, has a great commercial potential. And another point that was quite clear from the user feedback is that the calibration of the models that are resulted from the automated process that translates the BIM information to business performance simulation is of paramount importance, because this is the only way to reduce the gap between simulated and measured accuracy and provide renovation measures, recommend renovation measures that could provide the expected results with regards to energy efficiency for the specific for its renovation project. Part of the renovation support system is the BIM performance simulation. Actually, this is the most important component of the decision support system, because it's the most complex one, because it's the one that translates automatically the BIM data and the occupant behavior data into business performance simulation, and invokes simulation engines, robust simulation engines like Energy Plus, and provide feedback to the user with regards to energy KPIs. And this is my last slide with regards to the construction phase, where actually we're talking about tools for the process modeling and simulation, workflow management and monitoring, but also work situation support. Actually, the lessons learned from this specific tools demonstration is that for small scale to medium scale buildings, the added value of components that digitize the process modeling, the workflow management, and monitoring is not quite appealing. They don't want to replace actually the end users' current practice that they follow to monitor, track, and planning the activities on site. But from the specific phase of the innovation project, we learned that the apps for workers and residents provide benefits for them. For example, the fact that they could learn and know when specific innovation works are taking place in their apartments was of paramount importance to schedule their activities as well, but also providing some support material to the end users, to the workers, sorry, through the apps on how to run specific course is also a lessons learned and another value to the end users of the innovation project. So that was my last slide on the presentation. Thank you.
Okay, thanks. Thanks to the others. And now we are going to have Pedro Mena from the University of Porto for another testimony. Yeah, less about maybe renovation, but more about circularity, quite the topic, and how BIM and maybe more broadly data management can help the assessment of circular economy.
Thank you, everyone. Okay, so we're here presenting Green Circle project. It's the only one that doesn't have BIM on the acronym, but actually it has, but we are a bit more focused on the data part or the construction products data that will, I would say, enrich the 3D model
The motivation to start this project comes back to, say, the end of 2018, when we were, our colleagues in Trondheim University and us in Portugal were, say, dealing with construction products. We had several manufacturers that wanted to become more digitalized, so they wanted to provide, we provide solutions for that. On the other hand, we were engaged with a lot of product manufacturers that wanted to deliver some data on their products in PDF. They were, say, eager to, say, spread an Excel spreadsheet, but they would like to maintain their phones on to, say, disclose some of the characteristics of their products to design teams. And these design teams and all the stakeholders across the value chain have this problem. They want data on the products, different data for the same construction phase, but this data is needed across the construction process, and manufacturers say, go and see the declaration of performance in PDF, interesting but not so digital, call me, or what is that you are asking for? And this, what are you asking for the situation that we was EP data and others. We also identified that there was a gap between the policy and the strategies on sustainability and digitalization. And owners, public owners that we were working with and our partners on this project were telling us that we want to become more digitalized, no 3D models, because we don't have computers nor the funding to get Revit or other modeling tools, but we want to become more digitalized. But on the same side, or on the other side, we need to do green public procurement. So how should we accomplish this? How could we improve the awareness of the industry in Portugal and in Norway with this? So we figured out that data templates with the relevant and trustworthy information, not 30,000 characteristics, but let's start with 30, 50, the ones that are possible from the construction manufacturers, and the ones that are interesting, relevant for owners and for the whole construction process value supply chain. And also try to set up a framework how this digitalization could start. So these templates, digital building logbook, now we have product passports or digital product passports, and